Hey guys, Mrs. Traber here. Today we're going to talk about congruent triangles. Our learning target is you'll be able to identify congruent triangles by first determining the triangles who are similar and have a ratio of corresponding sides of 1 are congruent. And then nextly, we'll know what's successful when we can understand side, 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 and angle, angle, similarity, and congruency go together. Let's jump in. Here is our first situation. I want to know first with this picture how many triangles you see, how many lines of symmetry you see, and how many pairs of similar triangles. Take a minute, pause this video, and think about each of these three questions. All right, let's jump in. For triangles, I see 1, 2, 3, 4, 5, 6, 7, 8. I see 8 triangles. There's the 4 little ones, then there's this half and this half, 6, 7. 4, 5, 6, and then there's this one and this one, 7, 8. So there's a bunch of them there. Let's next think about lines of symmetry. For this one, I could cut it down the middle here, 1, 2, or diagonally 3, 4. So 4 lines of symmetry. Pairs of similar triangles. There's a bunch actually. I'm not going to answer this question, but I want you to be confident on what your answer was. Let's jump in. We know there are 3 different types of triangle similarity conditions. As a review, you have side, side, side similarity, where there's 3 sets of proportionate sides. You have side, angle, side, where there's 2 sets of proportionate sides and an included congruent angle. And you have angle, angle similarity, where you have 2 pairs of angles congruent. Really, at least 2, because if you have 2, you have 3 as well. I want to know first, as a review, are these triangles similar? Are they side, angle, side, 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 angle, angle, or are they not similar at all? Let's look and see. I was given all sides. I was not given any angles at all. So already I'm thinking if they're similar, I'm going to have to shoot for side, side, side. So let's see if they're proportionate. I'm going to match up little to little. So little side to little side, that's 48 and 8. Medium sides are 14 and 72, 14 and 72, and the big sides are 84 and, ooh, wait, I messed up, 84 and 14, yeah, never mind, I started to label it wrong, 84 and 14, oh, this should be a 12, there's my mistake, going too fast, 12 and 72, 84 and 14, where did I mess up? Let me start over. All right, let's start this one off and see, are these triangles similar? Is it side, 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 angle, or angle, angle, or maybe not at all? Now, I notice I'm given all sides. I don't have any angles given to me. So if I'm going to try for any of these, I'm trying for side, side, side. Let's match sides up and see if they are proportionate. I've got large side 84 goes with large side 14. 84 and 14. I've got medium side 72 and medium side 12. 72 and 12. And I've got the small side 48 and the small side 8. 48 and 8. Let's see if these are each the same decimal. Let's see, 84 over 14 is 6. 72 over 12 is 6. 48 over 8 is 6. So since they are all 6, they are similar by side, side, side similarity. Let's move forward. Here's another one. Take a look at it and see what you think. Did you say side, angle, side? If so, you'd be right. We have this vertical angle that's congruent, and I also have the set of sides where the small one, 8 and 28, go together, and the longer one, 14 and 49, also go together. If I try to see if these are congruent, similar, I would have to check these numbers. 8 and 28 is 0.29, and 14 and 49 is 0.29. So since they're the same fraction, we can say they are similar. Here's another one. This one was quick. You were given the 61 and you also have a set of vertical angles, so there you go. Angle, angle, no work to be done. My last one here, let's look at. It looks like side, angle, side to me since I've got a vertical angle pair. And I notice these ones are both 16, so this one's an isosceles triangle. The other one, however, is not an isosceles triangle. So these are just not similar. Done. Now that we reviewed similarity, let's look at a proof with similar triangles. So here's 2 triangles, and they are similar, but I want to prove it. So knowing that we have our 3 options of conditions of similarity, I want to see which one we'd use here. I have all sides, so I think I'm going to use side, side, side. sometimes when I'm writing a 2-column proof and I come up with the mindset with what I'm doing, I kind of write off to the side my steps. I'm going to do side, 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 and then my last reason when I have the triangles be congruent, base similar, is that I'd have side, side, side similarity. So let's jump in and do just that. The first set of sides are the little ones, 4.5 and 4.5. So I've got 4.5 over 4.5. In the statement side, I have to put the letters that go along with these. So this is B, C, and ED. And this is equal to 1. My reasoning is because of ratios. My next set, the medium side is 6 and 6. So 6 over 6 is equal to AB over DF. And 6 over 6 is also 1. Lastly, the long side 7.5 and 7.5. This is AC and EF. That equals 1 as well. I can finish myself off and notice that I've got triangle ABC, which is similar to triangle. Let's match these up. I went from A to B, that's down the medium, then to the short. Okay, so medium, then short. So FDE. There we go, we have similar triangles. Now take a step back for a moment and notice, are these triangles just similar, or are they something more? What was the scale factor? Kind of times 1. It's the same triangle. It just kind of got rotated a little bit, or maybe reflected, but it's the same triangle. So of course they're similar triangles. What we actually call these type of figures is congruent. Two figures are congruent if there is a sequence of rigid transformations that carries one onto the other. Like for the example in the last one, it looked like it got reflected or rotated. You could also say two figures are congruent if they meet both of the following conditions. Number 1, that they are similar, and number 2, they had a common ratio of 1. I want to know next if these two triangles are congruent, so let's see if we can figure it out. Let's first determine if they are similar. So I notice that they both have this angle that's marked as congruent, so I already have one angle. And then this angle CDB is a right angle, and it must be supplementary with angle ADB. So this is also a right angle. It has two angles, so I can tell it's angle similar. It also has a side in common. DB is in each of them. So since it's in each of them, it must have a ratio of 1. So since that's the case, we've checked both of our conditions for congruency, and I would say yes, they are congruent. Here's another one. Let's see. We were given a set of angles. We also have a set of sides, and we also have BC, which is in each of them. I can mark it congruent to itself. So it looks like I have, if I go around the triangle, side, angle, side, side, angle, side. Yeah, these are similar triangles for sure. So I could say that they're similar by side, angle, side. And then we also have a shared side. Since BC is in each of them, they have a ratio of 1. So yes, they are congruent. Here's another. We have two sides that are set as 6. I'm going to mark them as congruent, so I already see a ratio of 1. That's good. I also have a set of angles that are vertical and congruent. And then I was given these parallel lines as well. With parallel lines cut by a transversal, alternate interior angles are congruent. So angle ABC and angle DEC are congruent. So if I go around the triangle here, I have side, angle, angle. Is that one of our similarity conditions? It's not, so I can't say it's similar yet. Let's see if there's anything else I can mark up to fully complete this. I could also mark this angle and this angle. We've got enough angles now. So it's angle, angle, similar, and it has a set of congruent sides, so the ratio is 1. So this one, again, yes. Here's our next one. I've got these two triangles, they're overlapped on each other, but I notice angle D and C match, so I've got one angle already, and then angle CAB and angle DBA also match. So angle, angle, similar, and they share AB. It's congruent to itself, so they have a ratio of 1. So yes, they are congruent. That's all I've got for today, guys. We're going to look more at congruent conditions in our next video. See you then.